we do not know how much electricity data centers are using. And the amounts, and I've spoken to researchers who do kind of research for the US Department of Energy, and they're like, look, we've just had to, it's guesswork.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another episode of This Week in Green Software. And I probably should say welcome to Environment Variables too, the parent name for this podcast, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. Today, we're doing a quick check-in with my friend and Executive Director of the Green Software Foundation, Asim Hussain. Hi, Asim.
Hi, how you doing, Chris?
And if you haven't heard this kind of format before, we are pretty much doing a roundup of interesting news or news that has caught our interest in the last few weeks in the world of sustainable software to basically share some of our takes and provide a bit of analysis or the things that we've seen, basically. So that's pretty much it. We'll be sharing links to all the stories and all of the follow-on links that we do from this. And I think that's pretty much it. Asim, before we start though, I know I've just said you're my friend and you work at the ED, but can I just give you a bit of space to introduce yourself about why you have something to do with green software? Because I've just mentioned Executive Director, Green Software Foundation, but I suspect it might be a bit more useful to share a bit of background about where you came from in terms of professionally and where some of that credentials might be. And then I'll do mine and then we can dive into the story together.
Yeah, so Asim Hussain, based in the UK. My background and career throughout all the way to this point has been software engineering, and about 6-7 years ago, really started to look at kind of sustainability space. That's when we met Chris, did a bunch of things, then launched the Green Software Foundation, helped co-found it three and a half years ago. And I describe my job as, very luckily and very boringly being able to focus on answering one question and one question alone, which is how can we have a future where software has zero harmful environmental impacts? So I'm very excited to get on this call with Chris because I love getting wonky, and there's not many people as refined in their thinking as Chris, so we can really dive deep some topics.
That's very nice of you to say, and I assure you I didn't put him up to that. Folks, if you're new to this podcast, my name is Chris Adams. I am the Director of Technology and Policy at the Green Web Foundation, which is not the same as the Green Software Foundation, but we're fellow travelers. We're a small Dutch nonprofit focused on a entirely fossil-free internet, and we are members of the Green Software Foundation, along with companies like Microsoft, GitHub, and Accenture, and so on. I'm also the host of this podcast, and I actually met Asim in person for the first time ever at a unconference called OMG Climate back in 2019. So that's where the connection is. All right.
I love that conference.
I work at the Green Web Foundation. We publish open source software, very similar to how the Green Software Foundation publishes some open source software, but we also push out like reports and things like that. And I also work as one of the chairs of the policy working group inside the Green Software Foundation, because it makes sense to be working with other organizations with shared goals here. If you are new to the format of this, it's literally a news roundup. So it should expect hopefully some light entertainment and some interesting takes on this. We'll share links to all the stories that we discuss, and I think that's pretty much the general plan. Everything we share will be listed in the show notes. So if you are listening using something like Spotify or YouTube, please remember to go to podcast.greensoftware.foundation to actually find the links that we start talking about. All right then, I think that's pretty much it. Asim, are you sitting comfortably?
Yes. Yep.
Okay, you look pretty happy. So I'm assuming we're going to go ahead with this. All right then, let's look at the first story. Does that sound okay?
Yeah, sounds good.
All right, the first story is from the Register, talking about Microsoft testing wooden data centers. So the headline for this is that Microsoft is starting to move into the world of what you might refer to as CLT, which is cross-laminated timber. This is a new building material that's used for construction in general. But because a significant chunk of Microsoft's emissions, reported carbon emission the last year or two, actually came from the construction of data centers and the actual pouring of concrete. This is, in my view, this is actually quite an interesting one because it's one potential lever for talking about the embodied carbon associated with using the kind of software that runs in these data centers. And there are some honestly quite impressive savings, because the thing about wood compared to concrete is that wood can be a sink of CO2 rather than a source of CO2 emissions. Asim, I'm pretty sure you've had a look at this, and given that you used to work at Microsoft, you might have some kind of perspectives on this one, especially last time we spoke about data centers, we nerded out about the use of mushrooms in data center building materials as well, and you had some thoughts there. So I'll hand over to you. When you read this, what kind of crossed your mind, and was there anything you draw people's attention to on this one?
Yeah, I mean, I think one of the things I thought when I was reading it was, I don't think they did as good a job as they should have in communicating, what the overall reason for using timber is. So basically, this is all about mass timber and kind of why is building things wood even a good thing when we're talking about actually growing trees is a good thing. Surely like chopping the tree down that you've just grown to sequester the carbon is a bad thing. And the rationale behind mass timber is that, that's basically the problem is that, when the durability of a tree, I think, is considered to be about 100 years. I can't remember, I don't quote me on that. I believe there is kind of an official figure, which is when you grow a tree, like how long have you sequestered that carbon? And I think we've all agreed it's like 100 years. Whereas what happens, that tree then collapses, it goes to the ground, it decomposes, and it goes back into the atmosphere again. So it's only sequestered it for 100 years. Whereas the argument around mass timber is, well, let's take the tree before it's, dead and fall into the ground, and let's turn it into something else. It's a building. It's called mass timber. And through this process, we're effectively delaying the release of that carbon back into the atmosphere. And I think some of the things I read in the past are like 300 years. So it kind of like goes that way. Now, the theory there is it only really makes sense if you're building a building that's going to last for 300 years. I hope this data center is going to last for 300 years. That's a question in my mind. But yeah, that is ultimately kind of the argument of mass timber. I think the argument here, though, is a slightly different also because it's a relative difference between concrete versus timber as well. There's that aspect to it also, which, as we know, concrete is a significant emitter of emissions, irrespective of the fact that tree just got felled. I mean, the relative difference is significant enough that the durability, I don't think, comes into play that much. So it's kind of an interesting direction. I don't know if you saw this as well, Chris, but also OCP, Open Compute Project. Did you see they're exploring, is there carbon negative concrete? I can't remember. It was at the very least, it was less carbon intensive concrete, or it might be the kind of concrete which actually, as it cures, sucks carbon from the atmosphere.
Yeah, there's a few different ways you can you can essentially use concrete and in particular cement, which is the big source of emissions, to reduce those ones there. Because for the story we're linking to right now, when we talk about the wooden part, one of the things that's kind of touted is the use of timber instead of concrete can reduce the emissions associated, something like 2/3 lower emissions compared to steel, for example. That's one of the reasons why it actually is useful. And if you're swapping, say, steel out for wooden, there's also like a saving around 30% around is what is cited here. And that's largely because creating steel and creating concrete is incredibly energy intensive, but also just the actual process when you make concrete, for example, if you're using cement, if you're going to create cement when you're taking calcium carbonate, which is essentially limestone, there's a clue in the name, carbonate. You end up separating the carbon from the rest of it to actually make some of the materials, and that ends up being just emitted as part of the process. Even if the cost of energy was entirely free, for example, if you had entirely zero carbon heat, you still have that. So there's a few things that are kind of problematic about using cement, but there is actually a lot of new work going into either creating low carbon cement or even using different processes like using electrolysis, which isn't even relying on calcium carbonate, but using things like calcium silicate to basically precipitate out the necessary essentially like compounds you would need it to actually create cement. There's lots of things that are taking place right now. It's really interesting. And Microsoft is actually spending quite a lot of money in this field as well. We can share a few links to this because Microsoft is actually in many ways a complicated player in this role because there's lots of things they're doing in terms of enabling emissions. But when it comes to the actual construction of this, yes, they're building masses and masses and masses of infrastructure, like in the order of tens of billions of dollars each quarter. But they're also one of the few organizations that's spending significant amounts on the different clean kinds of cement that we had inside this. And that's the kind of thing I would respond to when you hand it over to me there.
Yeah. No, I think I'd also know that Bill Gates is also investing heavily. I know he's not officially leading the organization. He's not leading the organization anymore, but obviously there must be some influence there as well. So I didn't realize the carbon. So I actually assumed the carbon was from the curing of the concrete, but you're saying it's from the construction. It's from actually generating the raw materials.
Yes, I'm very quickly leaving my domain of expertise. So I'll share a blog post that I wrote when I learned a bit about this. Because there's a really interesting podcast about as interesting as talking about cement actually gets, I suppose, that actually dives into this by a guy called David Roberts on the Volts podcast, where he does an interview about how this is made, how there are different approaches that you can use for doing this, how you can do it entirely fossil-free. So there are some options that you have here, but there's also, it raises all these other queries about, okay, if you are going to do this, how do you move cement around? Because in many cases, cement has it sets in 90 minutes, right? So just like electricity is hard to store, things like cement can be very difficult to store. So there's a whole question about, okay, if someone wants to purchase this, how do they go about doing that? And that is how some of this gets a bit more complicated. So that's like one of the options. And I think if there's sufficient interest, it might be worth actually talking a little bit about reducing the embodied carbon and what the levers are available, because this story is about wood and we've kind of gone down a kind of cementitious kind of sidebar, I suppose. But there's a lot of interesting stuff happening with wood. For example, you mentioned the OCP, that's the Open Compute Project. There are actually 3D models of wooden data center designs. There's one chap called Carl Rabe, who has been running the wooden data center company for years, who's been doing this kind of work. And I find it quite interesting and endearing at the same time. There's something kind of pleasing about this. And you realize that this idea of cross-laminated mass timber ends up getting increasing amounts of mindshare because it's one of the ways that you can build relatively large structures for a lower carbon footprint. And for example, if you're in the UK and you ever go through London King's Cross, Google's shiny new headquarters uses all this kinds of this cross-laminated timber as well as one of their ways of reducing it. So it's very much seen as like one of the trendy materials that you might actually use because it aesthetically is actually quite pleasing. And the elephant in the room when we talk about using wood for construction is like, doesn't it burn down? Like we had the Great Fire of London, which kind of redesigned London, as it were, right? And it turns out that the actual tooling that you have, the actual kind of material like CLT, it actually is surprisingly fire resistant. It smolders rather than burning in other ways. And this is actually one reason that there's actually something that you might initially worry about, but is actually not such a concern, actually. So I think we've come up with a bunch of links that we should add to this for people who are interested in this, because it's one of the levers. And we know that this is increasingly, when you have organizations doing a massive build out of infrastructure, if they're going to build new buildings, then this is one of the tools in the toolbox for reducing the embodied carbon. And Asim, what's the letter in the SCI that we have for this then?
I, intensity? Or
embodied?
Embodied, yeah, sorry, yeah.
So that would be one lever you have for embodied intensity that is sometimes included.
Cool. And also, I think we should probably, correct me if I'm wrong, but just cement is, I believe, the last time I looked, 7% of global emissions. So that's why this is why are we talking about cement? It's 7% of global emissions, just cement. So finding alternatives is not just, an edge case. It's kind of one of the main things that we need to do.
Absolutely, yeah. So for context, that's about 3 to 5 times people's estimates of the digital sector. So this is one of the big ones that we need to be aware of, and it's essentially one of the most used materials in the world, basically, as well. We'll share some links to that because it's when you start looking into it, it's surprisingly interesting if you care about reducing the emissions associated with digital and you accept that a lot of these things take place in buildings, basically. All right, thanks for that, Asim. Should we look at the next story?
Yeah, let's do it.
The next one is about the other part of embodied emissions, actually. So this is a paper that was published, that initially published in Nature, but a preprint of it is available also on another website called networkd.org. This was actually talking about the e-waste challenges associated with generative AI. And essentially, one of the things that comes up with AI is that when you're using different kinds of hardware, while you can use existing hardware, like typical CPUs and things like that, a lot of the large providers and a lot of the kind of interest is gone into building new machines or new kinds of specialized infrastructure or specialized tooling like NVIDIA's chips and stuff like that. And this paper does a kind of material flow analysis of what this might look like if you project this forward over the next 5 to 10 years, for example. And this is actually, in my view, I think this is quite interesting because we often talk about the energy impact of AI. And one of the reasons that it's quite difficult to actually even get a figure for the embodied impact of actually creating chips. And when you move, if you're going to talk about, say, onshoring, moving the construction of chips to, say, to the EU or in America, that has knock-on implications on where the carbon emissions go and how visible they become, actually. Asim, I'll hand over to you for some insights here, actually.
I've not actually read this paper, so I can do what I normally do, which is give a wing off the cuff. But yeah, it's kind of interesting. You're right. The embodied carbon is still like the most stunningly hard thing to get. There's still only a couple of examples that everybody kind of interpolates from to apply to everything else. Sorry, just so what this article is saying is that there is a faster, or should we say, what's the term in the cloud space? Not turnover, but the length of time.
The useful life of a...
Yeah, the life. Is it saying that the useful life of AI chips is lower?
I think there's two things at work here. Yeah. So one of them is just the fact that people are using this particular kind of hardware, which may be more energy intensive. That's one of the issues. And there are basically, I think there's two arguments being made here. One of them is that because things are moving relatively quickly, a chip doesn't have the same kind of useful life cycle in the same data center, for example. So if you want to kind of keep up, you're incentivized to buy the next chip because it's that much more efficient than the previous chips, right? So there's this idea that by doing that, because you have this kind of compressed hardware cycle in order to keep up with other providers, particularly in the kind of given space, then that is actually a driver of creation of much more in the way of electronics, particularly because this isn't a very circular sector right now. So it's not like those chips are basically being broken down and then remanufactured into new feedstock for super efficient new chips. That's one of the things that is actually being that's the argument that's being made here. And that has implications here. I think the figures that are used in the abstract is something in the region of 16 million of cumulative waste by 2030, specifically for the tooling used for generative AI. So that's like that's a non-zero figure. That is something significant. I think when you look at this, though, one thing it's worth actually, and one thing that I actually thought was, if you've got this kind of endless treadmill, does that mean that these chips are being thrown away? And I'm actually, when I spoke to some people, I actually asked Boris about this. Boris Gomazaychikov, who's the AI lead at Salesforce. Yeah, I asked him about this and he said, that is one of the factors. But one thing we're actually seeing is that given that there's, in the last couple of years, because it was just so hard to actually get hands on any of these chips, even things which were not the latest and greatest, they still were being used. So it's not like these things are being thrown away entirely, right? It's not like they're going straight to landfill. But one of the problems we find is that there's very little data on the circularity of these chips to see if they are being put to use or if they are just going to essentially like landfill or not, basically. This is one of the big problems that we do have. And I would love to actually have some meaningful data on this, because it's one of the kind of generational shifts we're seeing in the sector right now. We've never seen so much money spent so quickly in this field with so little data being disclosed about what the knock-on effects of this might actually be.
Two thoughts popped into my head as I was reading this, well, the abstract and what you said, and from other conversations I've had, especially in some of the places I've worked. The latest chips, like why do people want to use, why do Gen AI and AI startups and AI companies want to use the latest chips? It's because dollar for dollar is cheaper for them from their perspective. It might cost more to rent those chips, but the AI job gets done sooner so overall it's just cheaper for them to use the latest generation of chips, and therefore it's more profitable for organizations. But I wonder if there's kind of this, and I don't know this because again, there's no data, but I wonder if there's this kind of constant, battle then to get the latest chips. Is somebody left holding the bag with kind of slightly older chips, which aren't as profitable anymore, no one wants to use, and then that's just, it's not kind of like this perfectly free market where everything, all the information flows and the prices of the older chips. Maybe it's just a mad battle for everybody to get the latest chips because that's the only thing anybody wants. And we're decommissioning, maybe we'll decommission these older chips sooner than the necessary just because of the incentives in the market. That's one thought I had. And again, based off of nothing. So there's no data. So take that with the usual pinch of salt. But the other thought I had was just looking at some of the stuff that's happening in the space right now, like moving forward. Like if I've forgotten the name of the project, I will find it and I will get it in the show notes. But there's, NVIDIA is now, they don't sell the boards. They don't sell like graphics cards. They sell entire vertically integrated units that you just like slot into a data center with everything baked in, the cooling baked in, all these kind of like because that's the only way you can get the true levels of efficiency is if it's like the Apple ecosystem. The only way to do it is everything is just owned by one company and it just does everything the way that product does it. So that I think will A, make things more efficient, but B, potentially make things more complicated when it comes to e-waste. What I mean? Like if there's like a load of graphics cards, maybe I was thinking in my head, maybe in the future, everybody's going to have really great gaming experiences because you'll have like, 5-year-old, everybody's going to have like a really amazing graphics card secondhand on their computer. But with these vertically integrated units, maybe that'll be a lot harder to do. I don't know. I don't know what they look like inside. I don't know if it's a bunch of boards that you can just unplug or whether they're just all soldered together.
So there are,
interesting feature.
You're right. So there's a couple of links that may be relevant for sharing this. So there's actually a really interesting piece by, I think the folks the AI Now Institute actually spoke about the supply chains associated and where the concentration is for the creation of these chips. Because when you have one or two extremely dominant players, then they're very much incentivized to not have too much stuff which is interoperable, because that means they end up being the people who get to set the prices. And we've seen NVIDIA, for example, briefly become the most valuable company in the world, eclipsing both Amazon and Microsoft briefly over the summer before falling down to being in the top 5 position, for example. So you do see that. And there is that is one of the issues that we do see, is that you have this kind of vertical integration increasingly being pushed by this. But you also do see various other kind of pushes for this. For example, we know that like various hyperscalers have been looking to break this reliance on a single provider by having their own chips. So Amazon has published they have announced a Trainium as an example. Okay. Google have been building their own chips, for example. Microsoft, I forget the name that they have for theirs as well, but a set that you have, and you do have AMD being in the kind of like far lower down compared to these other providers as well, in terms of like sales and usage, I suppose, because they do have some options out there as well now. Mm-hmm. But yes, you're right. The other argument, I mean, you could argue it from that. I mean, I think that the thing to understand is like everything has 15 different arguments, for it. So, your vertically alignment could be more efficient, but then you're right, it could be also vendor lock-in. It could be a bunch of these things all at the same time. And the arguments for, different, like Amazon, everybody having their own chips is also a pretty decent argument. I'm running on a MacBook, which has its own chip, because once you kind of vertically align, the efficiencies increase.
And so the argument from Amazon, at least, was like, we built chips that are optimized for the exact workloads that we run. And that's how we gain efficiencies. So there's kind of multiple things in this, but you're right, that makes it much harder from an e-waste perspective, because then instead of having the same, even just, I don't even know if they're all x86, they must all be x86. No, they're not now. No, not so. But anyway, there's more. It's much more complicated when you come into e-waste, when there's different protocols and different, architectures.
About this whole idea of the cost of compute going down beneath a certain figure. There's a link that I've added to the show notes from the publication Latent Space, called the GPU Bubble, which does explicitly talk about how the cost of rented GPU compute has changed over the last few months, and what might happen as you have like new clouds being available, and what the introduction of new chips does to the cost of some of the other kinds of compute available, like you mentioned here. That's probably, in my view, I think that's one of the most interesting pieces of analysis about where the cost of this might actually go. And it may be the case that just how in the 2000s, we end up with loads of dark fiber left around that we're still using now, as a result, when everyone had this massive build out for the initial .com bubble. You might see something comparable with AI, where we do have massively fast chips available for all this usage. So that could be the case, but yeah, it's a bit early now. We're not quite sure. I think that there's a bunch we've got there. Well, we've added a few links. So if any of this has been interesting to you, a listener, then there should be a bonanza of links available for you. Thanks for that, Asim. Should we move to the next one then?
Yeah, go on.
All right. So this is actually referring to the Green Software Foundation's, one of their projects called Real-Time Cloud. This, I think sometime in October, the steering committee inside the Green Software Foundation pretty much like merged in or approved the merging in of
ratified, is it?
Ratified the most recent work on Real-Time Cloud. Asim, you're in the steering committee, right? So maybe it might be useful for some of this to be explained a little bit to you, or like maybe you might talk about what this process looked like at your end, because I've been joining these meetings, but it's very much been the work of Adrian Cockcroft and Pindi Bullar really pushing this. So essentially create a data center level list of all the carbon intensity figures for the 3 biggest clouds. So if you run a workload on Microsoft or Google or Amazon, you basically have, in my view, the most complete open data set available. And where there has been information about the efficiency of a data center in the public domain, it's included. Where there's information about water usage, it's also included. And I'm really happy to actually finally see this get kind of ratified, because there is now something approaching a shared consensus view on what this data should look like. And I think this is the thing I would point people to, because I think this is actually used by some of the other software like Impact Framework and some tools like that, actually. Maybe, Asim, if I hand over to you to let you talk about what the process is when the steering committee inside the GSF ratify this, and then maybe talk a little bit about the Impact Framework thing, because there's some follow-on things that I might talk about after that. But I suspect that might be useful for people who are trying to figure out how they might use some of this information themselves when they're trying to quantify and manage the environmental impact of the services they're operating.
Maybe I'll just start off with that, actually. I'll just start off talking about how the Impact Framework team got involved. I think it was during the hackathon this year, and what we wanted to do was a mechanism where we could, help people like compute the carbon emissions of their cloud usage. And so, the real-time cloud was a data set at that point where it gave you regional information. So I forget all of it, but it was, PUE, power usage effectiveness. I think CFE was in there as well. It's
carbon-free energy for people.
Carbon-free energy.
Yeah.
Yeah, it's for some reason, it's dropping from my head which actual point of that data was needed for the hackathon. But the Impact Framework team went, wow, this is the data set that we need. And so they ended up building, I think the only thing we needed to add to it actually was the geolocation of the data center region, so that then you could do kind of good queries with what time electricity maps and things like that. So they ended up building a plugin for real-time cloud. We actually then turned into like a baked-in generic kind of CSV plugin, which was a good call. And so now you can use this data set as one of the inputs to a computation, an end-to-end computation for your cloud usage or other end-to-end usage. That's how the impact framework team got involved, which is, I think, a really great example of kind of cross-pollination of work inside the GSF. And just in terms of like how the process is here, I mean, this is driven through the standards working group. The RTC project is a standards working group project. There, again, you've been part of it, Chris. It's a consensus-driven process. So the RTC group got together and said, we're happy with this data set. We're happy with the specification associated with the columns. And that's the way we see it. This is a project which is not just data, but the specification for what the column should mean. And this is our version of the data that we've published. Now, the goal ultimately is to get this into ISO so that if you wanted to disclose a data set, similar data set, and you were a different cloud provider, you could, as long as you exposed it with exactly the same columns, with exactly the same meanings. And that's the kind of power of standardization, is kind of getting everybody to talk the same language. Right now, I believe, Chris, that it's been ratified, but the process is that we're leaving it out there for 6 months for public feedback and broader review, with an aim that in 6 months' time, we'll take all the feedback, package it all together, and that's what we're going to publish into ISO, which will be another process. ISO is a process where you get reviewed by 175 country bodies, and then you've got to respond to their feedback and make adjustments. And if you have, once you make those adjustments, it gets accepted and you get into ISO.
And when you say ISO, you're referring to the International Standards Organization, essentially the place where people standardize on stuff, basically, right?
Yeah, one of the main ones. Yeah. And one of the things we've noticed what does it mean? Why is it important to get into ISO? It's important to get into ISO because all that everybody's really looking for is, should I use this? God, is this the right thing to use? Should I trust this? And the reason why people are really keen to use kind of ISO standards is they know it's going through an incredible consensus and review process, both internally at the GSF. Not only did the RTC team had to agree, then the whole standards work group had to agree. Then we send it out to all of our members to see if they agree. And if they don't reject it, then it goes to the steering committee, who have this ratification process. And in all honesty, I get very nervous at that process because I'm like, yes, it is their right and they do ratify things. They've never abused it. But it is kind of, I want people to have the conversation as part of the RTC team rather than right at the end of that whole journey as a ratification process. But we see it as more like in ratification, typically, in the physical world, is the actual process of everybody getting together and celebrating and signing a contract. It's actually more of a celebratory thing. It's ratified. So that's the way I think people should view kind of the ratification process. It's the celebration from the steering committee that, yeah, we signed this. We love it. We want it to go ahead. So that's that.
Okay, cool. Thank you for providing the extra context, because I work on one side where we're trying to figure out how to get the data into a data set like this. But I wasn't so aware of like, okay, who gets to shoot this data set down before it gets actually used in various places? And the thing I might share with you that is probably of interest now is that given that we know there are various laws around the world that there's like, for example, in Europe, we have this law called the Energy Efficiency Directive. I'll share a link to a post that we have published at the Green Web Foundation called Happy EE Day to those who celebrate. This is specifically about the fact that there's data that's been collected at a data center level, which is actually higher resolution than this kind of regional level that you might see here, which in my view, basically sets out a way for all the other the providers who aren't just Microsoft, Google, and Amazon to have a way of sharing the same kind of figures, so that you actually start making you can start making comparisons between running a workload in one data center with one provider versus another one, for example. So that's some of the work that's going into this right now. And hopefully we'll see some more data come out, because we now have this data being published, or there are laws to kind of get this data published in various places. And there should be a data set coming out, I think early in 2025, for all of Europe, which is very extensive. This will be any data center that uses, I think, more than 0.5 megawatt of power. And given that most of the hyperscalers
That
use
is
tens
not
of
much.
megawatts, that's going to be thousands upon thousands of data centers. So it'll be interesting to see what actually comes out from this. And what we'll find in the next month or two is what data has actually been shared by providers already, basically, because we are starting to get glimpses of this. For example, in the Netherlands, we're seeing some submissions come to the public into the light of day. And I believe there's some stuff in Germany coming as well. So we will get some advanced notice, and this might be stuff that can kind of come into this, so we can start creating essentially an open resource of this information, so that if you're a operator of infrastructure, you've got an idea of what can actually measurably reduce some of the emissions on this.
All right, did you say it's definitely going to be a public data set? So
I'll share a link to, again, a little bit of a kind of like wonkish thing, basically, with the Energy Efficiency Directive in Europe, which is, all of Europe. Basically, that's 27 countries. There's two things. If you operate your data center, you're mandated to publish a bunch of data points like how much energy have you used? How clean is the power? How much of the power came from certificates versus on-site generation and stuff like that? It's quite detailed. And
when you say, sorry to interrupt, but when you say publish, do you mean like in terms of like a CDP where you have to publish to an authority who will then keep it secret, or...
Make publicly available. However, there is a kind of caveat which basically says if you're going to do this, you need to do this except in the case where something is considered a trade secret. So what we've seen is that some providers are sharing this information and some providers are not sharing this information. So this is the thing that we're seeing now. And
so now we know which data centers MI6 uses.
Basically, or we're saying which companies are being, or when companies talk about being really transparent, we have a way of seeing which companies are walking the walk when it comes to talking about transparency, and which ones are not being as transparent as their comms is saying so, basically. That's one thing we're seeing. However, even if you don't publish the stuff, you still need to report to essentially the European Commission, and they will be creating an aggregated data set that they're publishing next year. So that won't be like this data set run by Equinix used this much energy last year. They'll have some figures so that we've got an idea of how big this problem actually is, because it's 2024. We've been using computers in data centers for decades, but we have no real meaningful numbers at this level of detail. And even half a megawatt, 500 kilowatts of power, that's still quite that's a few racks at least, right? So that's still a bunch of data centers which aren't being kind of included. But this will give us an idea of, for the first time, just how much power is actually being used. And given that in Europe, they have binding legal targets to reduce emissions, they do kind of need to know this, because they said we need to halve emissions, more than half emissions by 2030. And if you don't know how much power you're using and you don't know how clean that power is, it's very hard for you to tell if you're on track or off track. So that's one of the things that will be coming out next year. And that's like, I'll share a link to me diving into this, because I ended up having to make sense of it myself, and I found it quite difficult to read a bunch of these laws, but I've shared my understanding as I do this, and hopefully that should be useful to other people now, because it turns out this data is actually being published. It's the first time people have done it, just like with other laws where people are figuring out how to report on sustainability with legal teeth for the first time. And it's a bit of a mess in certain countries right now.
I think the takeaway for people who might not understand is we do not know how much electricity data centers are using, and the amounts. And I've spoken to researchers who are doing kind of research for the US Department of Energy, and they're like, look, we've just had to, it's guesswork. We've sent questionnaires, and a bunch of people responded, a bunch of people didn't. We inferred the rest, and there's massive error bars. I mean, that's where we are. We don't even know. We can't project forward. So I think that's a really good thing, just to have some solid data to even know where we will be in 2-3 years' time.
And we're going to continue on this thread to come to the next story. So that's what's happening in Europe, and that's what we're seeing right now. But we know that the winds can change in politics all the time, and we've just seen a significant change in America. This is a story from Data Center Dynamics that's literally called Trump Won, Now What? And this is a bit of analysis about what we might see as a result with a new administration in the US, because in the US, we did see some things were looking actually quite positive in the world of AI. There was actually legislation around reporting on AI, just like Asim mentioned, and there was unparalleled investment in cleaner forms of energy. And now we've got a new set of people who are in power who take more of a dim view on climate change and unabashedly in favor of fossil fuels. Asim, I'll hand over to you because you said that there's a few things that caught your eye that you want to talk about here.
I don't want to get too political, and I'll try and keep it more to kind of, I don't know if the facts is the right word. But yes, okay, look, when Trump came into power last time, it was quite a challenge for our community. He pulled out the Paris Climate Agreement. There's a lot of kind of negative rhetoric, which I don't know if he led or he was just gave a voice to, about the climate change and the work that was being done. I think this time round, though, the reason I'm a little bit more positive, and it might be, I'll probably preface for this to everybody saying that I'm neither left nor right. I don't identify with a particular side. I identify with the side of, the fight that we're fighting. That's it. And so I see Trump as somebody who is somewhat influenced by the people he hangs around with and what he watches and what he hears. And even though these are two people that I think the left are particularly critical of, let's just look at it factually. There's Elon Musk, which is part of we don't know how he's related to the place, but he's going to be he has a voice of Trump. And this is a guy who, whether or not what his personal beliefs are in this space, he has a solar power company, he has an EV company, and we've seen Trump's rhetoric change to be more pro-EV, at least up until, the election completed. So my hope is there's going to be a little bit of influence in that direction. One of the things about Elon is he was part of the government committee on sustainability, I think it was, and he dropped in protest of Trump leaving the Paris commitment. So he was very against that whole process and he was very pro-climate. So there is some positivity there. I'm hoping that there'll be some influence to him. And this is all what I was thinking before yesterday. I'll tell what happened yesterday. This is what I was thinking before yesterday. That might be more of a positive influence there. And RFK, I think a lot of people know him for one aspect, but maybe people aren't aware of the fact that his entire career is as an environmental lawyer. So that's what he spent his entire career at. He was a professor, I think, Pace University, teaching environmental law. He has litigated against many companies on a pollution perspective, including a big case against Monsanto. And he has been a big supporter of not just climate, but kind of environmentalism and caring for our planet for a while. And I know he's got other opinions which are of a different spectrum as well.
Who needs vaccines?
But let's just focus on what we want to focus on. So my hope was that Trump would kind of listen, be influenced by this space. That was until yesterday when Trump kind of announced some of his first appointments, which now turn out to be quite war hawkish. And so the whole story of I'm the peacemaker and I'm going to bring peace to the world is, I think, a bit more up in question. But there's still some hope there. He has made all his appointments, so we'll see what happens. That's for me what I'm looking at right now is I'm looking to see what actual appointments he makes. And I think that'll be the judge of what his tendency is going to be like. And I think we're going to know pretty shortly in the next couple of weeks. Is what I'm saying nonsense and he just took advantage of these people and then will do whatever he wants now he's in power and listen to the people he used to listen to? Or can he be swayed somewhat? So I'm probably not as depressed than most people. I'm still a little bit hopeful. But yeah, that's just kind of my very pragmatic viewpoint on this. That's kind of where I'm thinking.
Or the environmental impact of digital services. So there's one thing. It looks, given like you mentioned things like nuclear, for example, you have, and you actually mentioned specifically Robert F. Kennedy, who was one of his achievements, essentially, or policy achievements that he's touted before is being able to stop nuclear or to get nuclear plants closed down. That is at odds with some of the other work or the other kind of commensurate where there seems to be a lot of interest in. Nuclear is one of the ways to have a lower carbon form of energy. And I'm actually not sure which way this is going to go, to be honest. Because one thing we've seen is that the current laws right now, which were passed under the previous or the current administration, things like the Inflation Reduction Act, they work out to be really good for tech companies right now. So if you, for example, right now, it's not actually that well known, but let's say you see these announcements by kind of Google or Microsoft and Amazon talking about we're going to deploy a bunch of new data centers and they're going to all be powered by nuclear power, for example. If you look at how that's being paid, you'll see that essentially half the cost of that is coming from the government themselves, right? So you've got essentially your 50% subsidy to the largest companies in the world. And you can imagine that there's going to be a lot of pressure to hold on to that kind of policy set up, because that is worth literally billions and billions to existing tech firms. So that might have some impact on like the environmental impact of the energy that we use. But you also have this thing where you've got someone who's very keen on in expanding America's role as the largest producer of fossil gas right now. So that has a flip side. I'm not quite sure which direction it's going to go in, but it does look like it's going to be bad news for, if nothing else, wind. Doesn't look like it's going to be great. So the idea that one of the knock-on effects of this might be that
Elon doesn't own a wind company. So
but one thing that might kind of bring up from a kind of operational point of view is like, do you end up with a slightly less volatile grid because you've got a bunch of huge amounts of money being thrown at stuff which is either fuel-based, so it's kind of can be dispatched internal all the time, or nuclear, regardless of your feelings of that, which is a kind of a steady thing. That might have some implications on what you end up building as a result. Because I could start talking about all the other kind of, all the justice themes around that, but we're coming to time and I don't want to start on that because...
this is a rabbit hole. But yeah, I think probably you and I agree the next couple of weeks are going to be very interesting, and I think it's going to affect kind of the next 4 or 5 years in quite meaningful ways.
And the other flip side of this might be, if you now have this scenario where you have tariffs, which massively, like we've seen stories, we'll share a link to some stories inside this, where it looks like, assume under this kind of tariff regime, you would have basically laptops and electronics doubling in price. If you suddenly just doubled the cost of embodied stuff, of hardware, that's going to create other drivers of what you actually then choose to do. For example, you might hold on to hardware for longer because it's so expensive to replace now. It's twice as expensive to replace. So that might change the steps that people end up being incentivized to do under this kind of regime, for example. So there's some stuff there. And it's also worth bearing in mind that's just America is obviously one of the largest sectors, but it's not the only one in the world. Like there's also China, and there's all kinds of stuff happening in China, for example, as well. I'm going to give you the last word, actually, if that's okay, Asim, because you were literally in China talking about green software. And I wonder if there's any things that caught your eye that you might kind of point people to, or if there's any kind of things you saw there.
Well, no, I think you're talking about, I've got a few more minutes. You think you're talking about this. I can comment on that, but I think you've got to comment first on the actual,
It's a lot of the time when we talk about green software, we talk about stuff that's happening either in Europe or North America, because that's where the majority of the money is being spent in Western markets, like quote unquote Western markets, right? But China is also like the second largest source of emissions, probably, second largest economy in the world right now. There's a huge amount happening there. And we tend not to see so much of that, but there's actually someone who I've been starting to follow, an analyst called David Fishman. He's been showing some really interesting stuff, because you basically see some, in my view, quite radical decisions being made in China to actually impact the environmental consequences of using digital services. There was a thing published in May, basically this energy efficiency and carbon reduction action plan. And the short version of this is basically by the end of 2025, the goal is to have, I think, 80% of all the new data centers that are being created, 80% of their energy has to be coming from fossil-free sources, renewable energy, which is, when China gets something done, they move incredibly quickly, and there's massive human rights consequences as a result of that. But in this one here, this is something that a lot of us are sleeping on. Like we talk about, say, my organization talks about fossil-free internet by 2030, and we might see the UK government saying we can achieve a carbon-free grid by 2030. In Germany, there is a target for 80% renewable energy by 2030. And then in China, for data centers, they're talking about, 80% by the end of 2025. The caveats I need to share, This is stuff which is translated from the actual Chinese documentation. So it's going to be hard if you don't speak Chinese. And that's why I'm pointing to the analysts who operate in this field and share some of this. But it's just so much more, moving so much faster than we are. And it's something that we don't really have that much visibility on. I think it's worth actually being aware of if we think about the kind of global picture for this, because you can come away with the idea that, okay, there's an election take place and that means there's not going to be anything happening in green software. But yeah, the world is larger than just North America, for example. There's stuff happening in other parts of the world. And in many ways, they are being more aggressive and more ambitious on climate than we've seen before, basically.
So my kind of like one addition to this, and I want to acknowledge this is like an anecdotal single experience of a human being who went to China, but I went and I was part of an IEEE conference, and there was a specific track, a specific room focused on sustainable software. And so there were a number of players there who, obviously in China, actively involved in, tech sustainability in China, some data center operators, smaller data center operators. We didn't see Alibaba. Actually, no, Alibaba were there. So we saw some like data center operators there. And I remember being part of a panel and the various questions. I remember just turning around. I think the EU AI Act had just kind of come into force, or just come into force at that time. And everybody was talking, in Europe, everybody's talking about the EU AI Act. If I was on a panel and I was talking to a bunch of people in the tech sustainability sector, they might not have details of the EU AI Act to kind of speak to hand, but if I asked them, like, what are some of the policies that the EU is instantiating, which is driving some of this momentum, they'd be able to rattle off like EU AI Act, CSRD, CSDDD. Maybe they won't be able to double, triple click into kind of the nuance of it, but they'll be able to rattle it out. I remember being part of this panel and I asked, what is the policies, I was thinking about EU Act. I said, what are the policies the Chinese, government is enacting, which is driving all of your amazing work that you're all doing? Nobody could mention one. It was kind of silence across the panel. And so that one anecdotal state, and I did some Googling as well, and I couldn't find much. Maybe that my problem, I'm Googling in English, maybe it's all in Chinese. I will acknowledge that. But I think from the takeaway from me, that is there does seem to be a disconnect between what is being stated at kind of the state level and what is being understood at the operator level. If this was Europe and if this was the kind of my world, our world, like as soon as there's a hint of a regulation in this space, we're all talking about it. Every person in this space is like using that as a reason for why you should invest more in the green space and this and that and the other. But that I didn't see that over there. Could be a cultural difference, could be something else, or it could just be that maybe, and again, I don't know. And if someone's listening to this and actually has better information, I would love for you to reach out and to help educate me. But this could just be something that's said on the state level, which hasn't operationalized down to low level. I don't know how it works over there. But what needs to happen for this kind of thing to operationalize? So we can have a conversation with Alibaba and Tencent and all these other cloud players. Where's their, page on their websites talking about how they're going to help meet this thing? If there's something missing here, and I don't quite know what it is, but it could be cultural, it could be anything. And I want somebody to educate me on this.
Do you know what? That reminds me of a piece of work we did last year with an organization called WikiRate, where we tried to track the top 10 domains in the world, which were by traffic. Do they have sustainability policies? What are they doing there? And some Chinese providers did come up, and they do actually have something inside that. I'll share a link to that because it wasn't particularly easy for us to find this, but that was some information there. And they were some targets that were, it's weird. Like the thing you see in China is there is this idea very much of like do more before you say rather than say before you do it. So inversion of what we often see in the West, for example. And like this is the thing, like China can be referred to as a totalitarian state in many ways, but that means that when you see a policy decision taking place quickly, like what do you want? Do you want green neoliberalism? Do you want green totalitarianism? There's like a whole, you can have all these kinds of.
Yeah, maybe it's just the way, because of the way Europe's different. So I would expect the conversations for, and I want to make sure I add to this. The panel I was on and the people I was speaking to were doing amazing stuff. They were doing
Was this
some
the ACM one that you're referring to?
IEEE one.
IEEE, so you were doing the talk.
Yeah, there was some great, even some data center operators. And I was like, you need to talk more publicly about the work that you're doing. But yeah, there is some great work happening over there.
Well, maybe we'll see some stuff come out of COP29 because COP28, digital and green digital came on the radar for the first time. Kind of really, because when Green Software Foundation sent me to COP27 in Egypt, it was basically not on the radar in the slightest. No one was really talking about it. So maybe we'll see something come out of COP29 as a result from this, because there were some initial movements inside that. All right, Asim, I think we've gone over a little bit on time, but this has been fun to catch up.
Yeah, great.
And I hope the kind of takes here, or the links, or at least maybe useful for people. I guess what we'll normally do is we'll just make sure that the things we did speak about, we've got some links to follow up so that people who are curious can follow on from this. And yeah, mate, really lovely catching up again. Let's do this again next month or something like that, all right? Take care of yourself.
All right. Cheers, Chris.
Right, ta-ra.
Bye.
Hey, everyone. Thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.